In this lecture, let's see how full adder and full subtractor work. So similarly like half adder, in full adder also we will add bits, but instead of adding 2 bits, now we will add 3 bits. So now we have the inputs x, y and z. Similarly like half adder, we will write the result of the addition in 2 digits and we will say that MSB is our carry and LSB is our sum. So for the first case we can add like this 0 plus 0, where this 0 is x and this 0 is y. So 0 plus 0 will result in 0. Then if we add for z, we will get 0 and we will write in 2 digits, where this digit or MSB is our carry and LSB is our sum. Then think of this pattern. Here we have our x as 0 and y as 1, so we will get 1. And then if we add z, where z is 0, so we will get 0 1, where 0 is our carry and 1 is our sum. Then for this pattern we will find our x is 1, y is 0. So at first we will find 1, and if we add z, then we will find 1 0, where this 1 is our carry and this 0 is our sum. And finally for this pattern we have our x as 1, y as 1. So at first we will get 1 0, and then if we add 1 again, which is for z, then we will get 1 1, where this one is our carry and this one is our sum. So similarly for the other patterns you can write the outputs for carry and sum. Now let's see how we can write the Boolean expressions. Here I have written in canonical sub form and then simplified it. Let's see how I have written the canonical sub form. For sum we have the outputs ones in these positions. For this one we can write x prime y prime z. For this one we can write x prime y z prime. For this one we will write x y prime z prime, and for this one we will write x y z. So I have written it like this. For this term and this term we have x prime common, so we can write x prime into y prime z plus yz prime. Similarly for this term and this term we have x common, so we will write x into yz plus y prime z prime. And we know this is the expression for y XOR z, and this is the expression for y XNOR z, so we can write like this. And we know that for XOR we need the expression like this, a prime b plus a b prime, and here we can see x is like our a and y XOR z is like our b. So here we have a prime b plus a b prime. So finally we can write x XOR y XOR z. So from canonical subform we have found the simplified subform. For carry we have the outputs ones in these positions. For this one we can write x prime y z. For this one we can write x y prime z. For this one we can write x y z prime, and for this one we can write x y z. We can see we have y z common in these terms, so we can take yz as common. So yz into x prime plus x, yz into x prime plus x, and we have x common in these products, so we can write x into y prime z plus yz prime. And we know this is the expression for y XOR z, and for x prime plus x we always find the result as 1, so this becomes 1. So our final simplified sub expression for carry is yz plus x into y XOR z. Now let's see how we can draw the logic diagram. For sum and carry we can see we have y XOR z in common. So at first we will take y and z as the inputs of an XOR gate, where we will find y XOR z, and then if we use another XOR gate with the inputs as x and y XOR z. Then finally we will find the expression for sum, because here we can find x XOR y XOR z. Okay, and for carry we need x into y XOR z. So we have taken the inputs as y XOR z and x to an AND gate, and we will find the output as x into y XOR z, and we need another AND gate for yz. So we have taken the inputs as yz to an AND gate. Thus we will find yz as the output of this AND gate, and finally we will use an OR gate, and this will give us the result for carry. For full subtractor we need to find x minus y minus z. So let's see how we can find them. For the first pattern we will find 0 minus 0 as 0. So this 0 is our x and this 0 is our y. And if we subtract z from the result of x minus y, then we will find 0 again. So this is our difference. And as we didn't borrow anything, our borrow is also 0 in this case. For this case, our x is 0, our y is 1, but we can't subtract 1 from 0. That's why we need to borrow 1 from the next position to the previous position. And as for binary we have the base as 2, so we will add 2 in the previous position, that means in this position, and then we will subtract 1 from this 2. So this will give us the result 1. And as we have borrowed, so we will take 1 here as borrow, and after finding the result of x minus y we need to find x minus y minus z. That's why our difference will be 0. Then for this pattern we have x as 1, y as 0, so we will find the result of x minus y as 1, and then if we subtract z, which is 1, we will find the result as 0, so our difference will be 0. And as we didn't borrow anything, so our borrow will be also 0. Then for this case, our x is 1, our y is 1, so x minus y will result in 0. For z we have 1, but we can't subtract 1 from 0, that's why we need to borrow. And when we borrow, we need to borrow 2, that's why. So after subtracting 1 from 2, we will get the difference as 1, and as we have borrowed, we will have the borrow as 1. Similarly we can check the outputs for other patterns. Now let's see how we can find the Boolean expressions for difference and borrow. For D we have ones in these positions, so for this one we will write x prime y prime z. For this one we will write x prime y z. For this one we have x prime y z prime. For this one x y prime z prime. For this one x y z. So I have written it here. From this term and this term we can see we have x prime common, so we can write x prime into y prime z plus yz prime. And between this term and this term we have x in common, and we can write x into yz plus y prime z prime. And we know this is the expression for y XOR z, and this is the expression for y XNOR z, so we can write like this. And we know that this is similar as x XOR y XOR z. Now let's see how we can find the expression for borrow. For borrow we have 1 here, so we will write x prime y prime z. For this one we will write x prime y z prime. For this one x prime y z, and for this one x y z. From this term and this term we can see we have x prime y common, so we can write x prime y into z prime plus z. And between this term and this term we have z common, so we can write z into x prime y prime plus xy. So finally we can write the expression like this: x prime y, because this will become 1, plus z into x XNOR y, because this means x XNOR y. Now we can easily draw the logic diagrams for difference and borrow. For difference At first we can take the inputs x and y to an XOR gate, which will give us the result as x XOR y, and then if we take this output to the input of another XOR gate with another input as z, then here we will find the expression for D, because here we will find x XOR y XOR z. For borrow we need x XOR y. We have x XOR y here, so if we put an inverter and take this to the input of an AND gate with another input as z, then here we will get z into x XOR y. We need another AND gate for x prime y, so this is our x prime and this is y. Therefore this AND gate will give us the result x prime y. Finally we need an OR gate where the inputs will be z into x XOR y and x prime y. So this will give us the result as x prime y plus z into x XOR y. So that's all for this lecture. See you in the next lecture. Thank you.